Hi everybody, this is Sonia England and this is my week 15 presentation about a technology event. And I'm kind of a NASA geek, so I chose to study and write about the InSight probe landing on the surface of Mars. It successfully managed that on November 26th, just a few weeks ago, which is a pretty big feat, all things considered. Most of the times when humans send probes to Mars, they crash instead of land. So Mars is really more of a graveyard of dead robots than a wonderland full of successful missions. So InSight's mission is different from previous missions. On the other times when we've successfully landed probes on the surface of Mars, we seek to study the surface. So we tell the probes to drive this direction and go look at a crater, or climb up that mountain and let's see what's up there. And sometimes, like on the occasions when the probes have gotten stuck, and it takes actually months to get them unstuck to make sure it's not permanent, sometimes we have actually uncovered what some of the stuff just under the crust looks like. They did that one time where, I mean, everyone knows that the surface of Mars is kind of that rusty, oxidized color. It is literally rust. And when the wheels got stuck and they turned the camera down towards the bottom where the wheels were spinning, they saw more of a bluish powder that they had never seen before. But to a large extent, we only see what the cameras see. We've been able to watch sunrises and sunsets. We're the first generation of humanity that's ever been able to do that, which is cool. And we've gotten a lot out of those other missions. Surface temperatures, data about storms, etc. This mission wants to see what's on the inside of the planet. It wants to show us things that cannot be seen. And it is going to do that by... First task that it's going to do is measure the radio signals to see how much the planet wobbles. And that's going to tell us what the core of the planet is made out of, like lead, or I don't know exactly what the core of most planets is made of. I think ours is lead or nickel, or who knows. So that's going to be its first task. And just like Earth has a wobble, and that has a lot to do with, obviously our core and all that stuff. The second task is going to be deploying a seismometer. It's going to measure the seismic waves produced by Mars quakes and meteorite strikes. And it's going to tell us if the core is liquid or solid. So, again, it's, all of this data is helping us get a better picture of how did our planet form, and how do the planets in this solar system form, and what is the difference between Mars and Earth from the perspective of this place is a Garden of Eden, and Mars is just sad. I mean, it's amazing, and we all want to study it, and I think most people have that dream of, we think we're going to live on Mars eventually, and it's probably a good idea to do so. This is going to give us a better picture of how we can do that. And how come Mars didn't develop? It's actually closer to the sun. There's obviously a lot more science in it than that. It's a smaller planet. It's slower rotation. Doesn't have a magnetosphere, you name it. There's lots of reasons why that planet is not as habitable. But the third task it's going to do, and this one is by far the coolest, I think, is it's going to deploy something called the MOLE. And it's a device that's going to drill 16 feet down, and it's going to take the temperature inside of Mars. And so, like I was saying before, it's going to tell us the difference between our planet and Mars. Why do we have liquid water and just these massive changes in temperature across our entire planet and all those different biospheres on our own world? And the entire surface of Mars is basically just cold and nasty windstorms and radiation and you name it. So it'll also tell us what is the higher probability that there is water there. Liquid water, more specifically. If we have to work very hard for our water, initial colonization is going to be tricky. So could the temperature being warm enough mean that there are pockets of liquid water beneath the surface? And the other reason why liquid water, it's not just for colonization, but where there's liquid water, there's life, as life on our own planet would indicate. So, and as far as what does this mean as technology news for all other technology, space exploration, not just sending this probe to Mars, but having a space station or sending up satellites, or when we send probes further out into the system, like when we did that death crash with the Juno probe into Jupiter. Was it a year ago now, I think? It's the ultimate test for any technology we design. It's the actual device that we're sending into space. It's the computer programs that are running it. It's the math we have to put in to make sure that all of those steps, thousands of tiny little minuscule steps, all work. And exploring space isn't just about the fact that humans love to explore. It drives us to design better and do better and be better as a people. I mean, we can all remember occasions when we've watched space movies like Apollo 11, and if something's going wrong in space, like the whole planet holds its breath hoping for the best. And on those occasions when like we've had rocket launches, even recently, if you think about like SpaceX and the Falcon launches, they actually air them like on CNN, and the watchship of people watching across the country and across the world is huge. So it seems like we have borders. It tears down borders between countries, having this big goal. We all want to go there, and we're not going to be able to do it if we're not a team, is basically. So it's more than technology. It's collaboration for humanity, really. And that's one of the reasons it's not just for space exploration, but all technology matters. It's a thing that can bind us all together. So, thank you for watching. Bye-bye.